Okay, so in this lesson, we will be first looking at the second part of the lecture series. So machine-to-machine communications. In the last unit about IoT, we discussed regarding the IoT definition, Internet of Things. And we discussed about basically about how we can use sensors and we can communicate some data from sensors to a certain local server, and from there the local server can access the internet, and the internet will store the data in a cloud-based data data center in a database, and some computation will happen there, and whoever customer who wants to access the system will access the data by accessing the cloud, and by if there's an application to the data that is that is connected to the database, then the customer will access the application through which it will access the data and the useful data. So machine-to-machine communication is a subset of IoT systems. So it is like a small application of IoT. So one application of IoT. So in M2M, we'll be basically looking at situations where the machine-to-machine communication will happen, and the machine, one machine will directly communicate with another machine using a certain communication technology. There are various technologies that can be used in here. So we talk technologies such as Wi-Fi, Bluetooth, LoRa, Zigbee, and any kind of like short range communications that are used can be used for machine-to-machine communication. Basically, machine-to-machine communication is a part of IoT. So if IoT is like a big set, one subset will be machine-to-machine communications, and these machine-to-machine communications will enable network devices to exchange information and perform actions. And important like feature is that they can perform the communications and the actions without human intervention. So that means that without human assistance, they can perform a certain task. In this kind of, this technology is applied in scenarios. So we can take some examples. So one example that can be taken is the factory automation. So in factories, if we are using some robots, for example, that who are engaged in a certain activity, we can use machine-to-machine communications to like enable communication within robots and from robot to the local server. Like if there's a network which is a local area network, which is having a local server, and which is connected to a group of robots, and the robots are connected to the local server. Apart from that, the robots can communicate within themselves directly as well. So in that case, they can have machine-to-machine communications. So they can have communication within themselves. That is one type of machine-to-machine communication. Apart from that, they can communicate with the server as well. So the second type of machine-to-machine communication will be happening between the robot and the server. So in these cases, actually, the decisions will be taken by the robots itself. and a human does not need to come and manipulate the functioning of the robots. Robots can make decisions by themselves based on the sensor measurements they're taking from their sensors that are installed in them. And the robots are able to like communicate that information to nearby robots and also to the server. So whatever the task they have been given, they can do it by themselves. So therefore, if we have given them some activity to do in the industry, they will do it by themselves. The humans don't need to intervene and support them. So that is one example of M2M. So if you have any questions, you can let me know. Then also another example is the smart meter monitoring of like applications where we monitor the water consumption, electricity consumption in houses. So in that case, like we fix some smart meters at the like location that we can measure the like flow of the water and the electricity, right? So this is one example of such kind of a meter that has been applied on water consumption. So as I remember, so this is like measuring the flow of water, and this meter is measuring how much of water has been consumed. After that meter collect that information, the meter will communicate this data to a certain local server, and the local server will send to a certain database. In that database, the computation will happen according to the previously configured methods, and finally the database the calculations will give us the bill of the water consumption of each of the houses that are connected to this service. So there are meters, smart meters, like multiple of them. We can say each smart meter is connected to one house. So these smart meters have connection to a certain local server, like they connect wirelessly or wired in wired communication to a certain local like access point, and then to a server where they will uh, collect information and do the data processing, and then the data will be shown to the customer using a certain application or some kind of a medium. So whatever the computation of data will also be done at the server. So all that process will be automatically done according to the previously configurations done previously. So that would be how basically like the M2M communication will happen. So like so therefore this is basically an autonomous process that is done with the help of machine to machine communications. So it is like an application which is basically applied in local area networks basically. So as you know, like internet of things is applicable in the global area network, right? Wide area network. So internet of things can send data from its own location to a certain access point, and thereby to local server, and the local server can access the internet through its connections through many routers and switches, and the internet will be able to transmit that data to any customer who's accessing the internet over the other end of the network. So in the machine to machine communications, the all the communications and the data like processing will be done in the local networks. So the collection of data and the processing of the data will be done at the local networks. So that is kind of one of the differences of M2M and IoT. Okay, so apart from that, I have in here like a summary of M2M communications, IoT communications, and the cyber physical systems. So M2M, IoT, and cyber physical systems are like very similar like terms. Um, However, they have distinct meanings. So machine-to-machine communication is a network communication that involves communication within a certain local area, for example, and it is basically doing like small tasks. Like although I mean they are doing some important tasks, they are they are only able to do one single task or one single communication, and then they are storing the data in the local area network. So basically the M2M is happening, doing some work in the local networks, and they are doing some important work. However, I mean, they are doing some automation, and they are doing mostly simple tasks. So these tasks have been previously given to them, previously configured, and previously announced to them. So they know that they need to follow a certain procedure. IoT, when we take IoT, it is like a system, I mean, a network that can access the total internet and then access any person in the internet. So this is applicable for wide area network communications. Apart from that, these IoT networks can store data in the cloud and do communications in the cloud and so on. So cloud-based data analysis, I mean, firstly data storage, and then data analysis can be done. So um, uh, in M2M, actually, we did not have the ability to access the cloud, basically because we are only doing the communication within a local area network. So in that case, we do not like access, I mean, we do not, I mean, connect to the internet. So we don't go to the internet in this case, right? So therefore, we don't have the access to the cloud servers. So therefore, in here, we don't have the ability to do cloud-based applications or cloud-based computations. So basically in M2M, we are doing local area network and computations. So in IoT, we have cloud-based facilities, right? So in comparison to M2M, in IoT, we have cloud-based operations happening. So cloud-based data analysis can be done. Apart from that, the user can actually manipulate data in here, actually. Users can manipulate data in here. They can manipulate data in here, right? If they want to give feedback to the system, that also they can do. The users can give feedback to the system. They can, like try to uh, update the system. The humans can update the system based on the required changes in the system. So likewise, IoT system is not completely out of human intervention. The humans are intervening in these IoT networks. So in contrast to M2M, in M2M, humans do not much involved in that after setting up the network and deploying it. In IoT, even after deploying it, we humans are interacting or intervening in the IoT communication process. Next, we have the cyber physical systems. So cyber physical systems is a popular term. So cyber physical systems is said to be the next like big advancement that is coming after IoT. So cyber physical systems are basically like a advanced version of IoT, which is having the ability to do a lot of things. So basically complex, I mean, firstly, they have all the options in the IoT system. So they can access the wide area network, they can access the internet, so they can access the internet and the resources there. So the cyber physical systems can access the cloud as well. So they can access the cloud servers, they can store the data, and so on. So in cyber physical systems, the kind of the difference is that at the at the network, in the network, at the edge of the network, where we are collecting some data, in these cyber physical systems, a complex task is happening. A considerably complex task is happening. So not only collecting data from the sensors, but also doing some, computation at the sensor end, and also making some decisions at the sensor level, right? So like if we take, for example, like a situation, if, for example, like that use different machines, the machines are able to take sensor measurements, and make decisions about what they need to do next in that situation. And then they are making decisions by themselves and taking actions, like moving valves in the system and moving motors, like switching on and off motors, something like that. Some, complex tasks normally done by humans, they're doing autonomously in this system, right? So cyber physical systems are, very like advanced system that controls like complex tasks. So complex tasks that can happen in, like, in situations like in the maybe in the urban, like city areas, one thing, and industrial areas. So if you are going to make a product or something, the machines which are in the factory can be trained using the cyber physical systems. And the cyber physical systems will produce the product according to the previously configured manners. But also, apart from that, they will also have the ability to address any kind of a challenge if some abrupt change in the environment or conditions happen. Like if some emergency happen at the industry, the machines will either like do some activity accordingly after taking the sensor measurements and after like monitoring the environment. So the cyber physical systems are able to address, like, sorry, like do complex processes. So these complex processes will be done at the edge of the network. Complex processes will be done at the edge of the network, and also the data can be sent to the cloud-based servers as well. And the another thing is, in the cloud-based server also, the data can be like autonomously analyzed, and the useful information can be given to the customers who are using this system. In M2M communications, basically the architecture looks like this. So the M2M network can either work as a wired network or a wireless network. So in M2M communications, if the devices are like this, the devices can talk to themselves directly, and also the devices can connect to the local server using a certain access point, and then they will connect to the wired network that will consist of routers and switches, and then they will connect to the server and the database, and then in there will be some application that will be shown to the customer. Then the communication, the same thing can happen using wireless networks. So in the only difference in these two diagrams is that in here we are using wireless communication to transfer the data to the databases. So in here we are using the wired communication to transfer the data to the servers. Next, in this table, actually, I am explaining basically the basic differences between machine-to-machine communications and IoT communications. So the Machine-to-machine communications use communication protocols such as Zigbee, Bluetooth, LoRa, Modbus. So Modbus is a communication protocol used in the industry. So basically for communication between, for example, robots or some kind of like automated machines, um, Modbus protocol is said to be used. So basically Zigbee, Bluetooth, LoRa protocols are used in IoT as well. So I think we discussed about that in the previous lectures. So anyway, like in M2M, we have these communication protocols that the machines can use to discuss with, do the communication with each other. So apart from M2M, like in IoT, in contrast to M2M, right? In IoT, we are basically having the ability to access the internet. So we are able to use the protocols like HTTP, COAP, WebSocket, MQTT, and so on. So these protocols are available in IoT um, uh, communication processes. So in comparison to M2M, so M2M communications basically concern about direct communication with the other device. So they will be using the Zigbee and Bluetooth LoRa communications to do the data sending, and they will process according to the previously configured configurations that are available for them regarding the certain activity. So then, apart from that, the M2M communications will have a homogeneous network where, homogeneous network means that the devices which are connected in the network are all same type of machines or sensors. So in that case, we have a homogeneous network. So in IoT networks, we have heterogeneous networks. That means that we have different types of devices connected to the network. So in that case, we have different appliances, different sensors which are connected to the network. In that case, we have used, since we have used like different communication technologies and protocols for different appliances and different devices, the complexity of the communication network will be higher, and we need to like maintain like stable connection with each of the devices. That is a kind of a challenge in the IoT. And then hardware versus software emphasis. So in M2M communications, we rely more on hardware, and we allow the hardware to do the the like communication and give out information about the process or something like that. However, in IoTs, we have software based facilities available. So in that, we mean that we are able to send the data to the internet, and then from there we can do some cloud-based applications and so on. So the cloud-based applications will be run mostly using softwares. So because of that, more software based applications, software based activities can be done in IoT in comparison to M2M. Then data collection and analysis, they can be done locally in M2M communications. So local area network communications is basically done in M2M. In IoT, we can do the data collection and analysis centrally in a centralized like cloud-based location, cloud-based server. So we can send the data to a cloud and do the computation there. So we don't have to work in the local area networks in IoT. We can work in the cloud-based like servers. And then application. So the M2M communication based network can be accessed by on-premise subscribers, right? So the users who are accessing the network, the local area network, will be able to access this M2M communication based outputs. right? So whatever if we are working in the factory scenario, the data collected by these robots will be stored in the local server. So the local server is accessed by the like industry, like people who are working in the industry, and they will be able to access that data. So in the IoT scenario, the people who can access the cloud can access the data. So with that, actually, we come to the end of that machine-to-machine communication based like theories. So now we are going to start the network virtualization section. So this is actually a very new, very emerging technology that we are discussing. So first of all, I, so the I would like to start with the question, right? So how can we deploy large networks that reduce latency and is cost effective, flexible, and secure, right? So as you know, now with the time, the number of devices that are connected to the public internet is increasing, right? So companies, users are using the internet, and they are connecting their devices to the internet. So with the time, the amount of devices that are there in the network, in the public network, has increased considerably. Because of that, once we are sending some requests to the internet, the data packets we are sending might might face a lot of challenges in the wide area network, right? So since this network is getting complex, and also it is getting bigger and bigger, it is sometimes not easy for us to send some data very efficiently from one place to another destination place, right? If we want to send some data from point A to point B, since we have multiple routes that we can use to access the device B, right, from A, then it is like difficult to find what is the best method, or like what can we do, like, or what is the low latency route that we can use, and so on. So and apart from that, these traditional networks depend a lot on hardware than software. So physical equipments are used to communicate or construct the network, and build the communication from one end to the other end. So a lot of physical equipments are used, and these physical equipments have to be configured before getting used. So each and every device has to be configured manually by people who are like constructing the networks, and this can take like months sometimes if we want to create some big network. So these large network infrastructures can give us a lot of like cost of implementing and updating if required. So if we are managing a network, so managing the network is difficult once we are relying too much on the hardware. So the hardware is expensive and it is rigid. It cannot be flexibly controlled. So because of that, once we want to launch new products or like update the current products, then we need to wait for a long time to get it deployed, to get it working, right? So we need to wait a lot of time to get some work done. So in that case, we are actually faced with a lot of problems. One thing is that, as I said before, once we are using hardware, we have to manufacture the new hardware. So that will cost some time, cost time and money. And secondly, once we are adding new services or updating other current services, then we need to talk with the vendors. I mean, we need to have a communication with the vendors and we need to establish the standards for the process, like how we are going to install that and so on. So the standardization process and the agreement between the vendors and operators takes some considerable time. So deploying these kind of networks will take time and cost. Apart from that, it's difficult to manage the system, configure the system and control the system once the network is getting larger and larger in size. So once it is getting larger, it gets complex, and sometimes we cannot really monitor the like large network that easily. So one of the solutions that have been proposed for this problem is the network virtualization, right? So network virtualization is proposed as the solution. So we will discuss about that. So network virtualization basically has this word virtualization, right? So what do we mean by virtualization? So virtualization, the word itself means that it is not it is not available in hardware or in physical sense. It is available in the virtual sense. Right? So that means this actually relates to uh, softwares. It is not something that we can touch. It is not a physical thing. It is a virtual, a thing which we can use to that we can use in the network and to do the network processes. So basically, network virtualization means we are using softwares more to do our applications, to do our actions. So network virtualization basically therefore uses a lot of softwares, and it can be basically divided into two main categories. So the first one is network function virtualization. That means network functions are software based functions. We are making network functions more software based. And then software defined networking. That means that we are defining the networking process using softwares, or we are determining the network traffic, controlling the network traffic using softwares. So the software addition is the new feature that is there with this network virtualization in comparison to the traditional networks. In traditional networks, we had more impact from the hardware. However, now we are trying to make it more rely on softwares. So the reason is when you are using softwares, we can reduce the costs. We can reduce the time that is spent on implementing the system, and we can easily control the system without much effort. So network function virtualization. So we will go there. So anyway, so network virtualization, we will talk first, like in general, what network virtualization means. So network virtualization, the word means that we are separating the software from the hardware or the network equipments. So basically that means that we are doing like a lot of functions in the network using softwares and without using much hardware. We are using hardware. We are not going to totally be devoid of hardware, because we need to physically connect our devices to the network, to the internet, and so on. For that, we need some connections, and we need to use wireless links or wired links. However, after accessing our access point, from there onwards, sometimes we can use like directly we can connect our connect our device, I mean data. We can send the data to the internet, and from there to the cloud-based server. So in the cloud-based server, we can run the network functions virtually using softwares, and then the cloud-based server will determine what is the optimum method to send some data from the destination point to the endpoint. Once that is decided from the cloud server will give the necessary control commands to the necessary cloud-based servers who are connected to them to send the data to the appropriate location. Once it is received at the appropriate location, the that location-based cloud server will send the data to the connected local area network. And from that local area network, the data will be sent to the receiver. So the virtualization means basically separating the software from hardware network equipments. So basically we are doing we are doing the software actions uh, in mostly in the cloud-based servers. Also, we can do in the local servers as well. But the work done at the network equipment level will be reduced. So at the routers and switches, the work done will be reduced. So the work done at the routers, switches will be reduced. Work will be reduced, uh, and that work will be done by a software which is installed in the local server or in the cloud. Then network functionalities can be configured. So network functionalities. So what do I mean by network functionalities? So the network functions, right, that are mostly used in networking, uh, such as routing, firewalling, load management, um, and link failure prediction, detection and prediction, and packet forwarding and controlling of the packet will be conducted using software. Those are the kind of network functions that we require. So such network functions can be configured using software programs. So what are the software programs? Right? Programs means like we can write some software like uh, program which we can write using certain set of lines. So these can be written using some programming language, and this program will be able to get some input data, and uh, uh, this program is doing some process and output some data. Right? So basically, the software will just input some data, process it, and output some data. So based on the application that we are concentrating on, we need to write the function correctly such that the function that we are expecting is done by the software program. So if you are doing routing, for example, the routing function will be done using a software program which is written using a script, and that software program will be able to give us the best method to route our data packet forward in a certain situation. So based on the data that we provide to this software program, it will give us what is the best method to route the data, or what is the method of routing the data. Then firewalling, load management, link failure management can similarly be implemented in software programs. So that is also one of the important things that has happened with the with the years. So the software industry has increased with its performance. Right, softwares now are able to perform really well, and they are able to replicate any function that is there in network. Now we are considering about networks. So they are able to replicate network functions. So the performance of those softwares have increased over the time, and they have proven that they can actually achieve something using the softwares itself. So without using much hardware. So they have now capability to replace a lot of works done by the hardware, and the reliability of such softwares also has increased over the time. So people now have like trusted softwares to do these tasks. And also, I mean, these kind of softwares can be installed in something called virtual machines. So virtual machines are something that we can call as some kind of a computer, right? Computer, some kind of a computer that we can uh, implement in a server, like inside this. I mean, as a software, right? This virtual machine will work as a software, right? It is a software, and that virtual machine is having a certain operating system. It is having some applications that it can run, and it can do some operations. So this virtual machine can work as a certain computer, but it doesn't need the hardware. It is a software program, and it is able to do some functions. So these kind of virtual machines can be used in the network as well for different applications. So if we want to do some routing or firewalling or any kind of network function, that network function can be installed in this one, in this virtual machine, right? So the software can be installed in this virtual machine. Right? So if we take that this is a virtual machine, sorry, this is a server that holds the virtual machine. That server is able to, uh, I mean, server is having the virtual machine. The virtual machine is able to install the software in its storage, and then the software can be easily installed in and removed from the virtual machine. Then the virtual, I mean, same server can be used for different purposes, and the same server can be used to like install different applications, different network functions. We can put routing, firewalling, load management softwares all in one server. So if we take this server as the single server, we can put routing as one software, then firewalling as another software. If the storage is not enough for firewalling, we can put a portion of the firewalling in this machine, and we can install the second portion in another server and in another virtual machine that is installed in that server. Then we can have another uh, like function installed in here. So likewise, we can put in multiple network functions in the same server. So this will reduce the amount of work, hardware that is required to do multiple network functions. And then we have the like another graph showing how we can easily use the network function virtualization in different scenarios. And so we can have our software that we have regarding a certain network function. So we have a network function such as routing, for example. We can install that in one of the servers, and then the function can be moved from that location to another location easily whenever we need it. So NFV is moving network functions from dedicated hardware appliances to software-based virtual machines. So the software-based virtual machines will hold the network functions, and it is also possible to package each of the network functions in one or more virtual machines. So as I said before, if we have a certain virtual machine, then we can install multiple softwares regarding different network functions such as routing, firewalling, load management in one virtual machine itself. And then that virtual machine can also I mean we can put the same network function in one or more virtual machines as well. And then the functions that we installed in a certain network virtual machine can be moved from one virtual machine to another. Apart from that, hardware is anyway needed to cater the needs of the virtual machines. So we need to give a certain server to install the virtual machine inside it, and then only we can apply this network virtualization. Then we have also, I mean, the next section of the network virtualization, which is about software-defined networking. So now we talked about network function virtualization a little bit earlier. So in here, after doing the network function virtualization, now after doing that process, that means we have given all the, like, we have configured the, like, virtual machines. We have configured the virtual machines, right, that we are using to uh, do some like action like routing, firewalling or something. We have configured the virtual machines. However, now we need to do the communication. So we need to connect our, like, virtual machines based server with another server and another virtual machine, right? So in order for us to do the communication, we need to have a standard method. So in there, we actually use the method called software defined networking. So software defined networking must be applied in these systems to control the traffic between the servers and other, I mean, the data, I mean, forwarding components, right? So mostly, I mean, in I mean, network virtualization, we will be mostly working with these servers, or like, uh, even we can use routers and switches as well, right? So it depends on whether we are applying or whether we are whether we are using this network virtualization in the cloud or in the local premises. If we are using in the local premises with the routers and switches, we can implement this scenario in using uh, routers and switches, and we can give the commands to these routers and switches using a certain controller. So basically, the each of these routers and switches will be configured using, like, it should be configured using softwares, which will do the network functions. So network function virtualization based routers can be used, and then they have to be controlled with a certain other controller, which is known as SDN controller. So this SDN controller based technology, or the controlling of the data transfer, is known as software defined networking. So we will get into that further. So basically, like, once we want to send our data from one network component to another network component, the data has to be sent using some commands that are given by a central server, which is known as the controller, I mean, SDN controller. So this controller is a centralized controller, and it will give commands to each of the servers which are involved in the data communication on how to do the communication. So software defined networking is basically about using software based controller to control the data traffic. So in conventional networks, the routers and the switches that are combined together to form the network have to do the decisions at those device levels on how to send the data forward. So a certain router, for example, router A, has to decide whether it is sending the data to router B at a certain instance, or router C, right? So it needs to decide either it needs to send to this router or this router based on the tables that it has already made regarding the data traffic available in the network. So it has a certain routing table. We can call this as flow tables or routing tables. And those tables are used to like consider what is the best method or what is the best path that can carry the data forward. So depending on the data traffic available in the other paths, so it's sometimes better to take the less traffic path to send the data. So in that case, the router has to do the decision. So every router has to make a decision once a certain packet arrives. So all the time, the routers have to do the consideration or decision making process. How to send the data forward? Like in what path I need to send the data forward. In that case, the traditional network has some issues, right? So once the network is getting increased with the time, if each of the routers make those decisions all the time, then some lacking or lagging happens, right? So some kind of latency is getting added to the communication, right? So like every router makes some decision, so then some lagging happens. So because of that, the traditional network infrastructure might not be the optimum way to send the data quickly across the network from one end to the other end. In that case, now they have, like, the experts in this field have proposed the SDN controller. SDN controller is able to give the action that need to be performed at each of the routers to the routers. The SDN controller is like telling the routers what to do. The routers will just follow the commands given by the SDN controller, right? So the SDN controller is like is having the total map of the network. It has the total map of the network or the topology of the network. So the SDN controller is able to see the total traffic, total network traffic. And therefore, like if a certain request for data transmission is coming to a certain switch, then SDN controller will check the entire network and decide the optimal path to send the data from one end, one point to another point. Optimal route to send the data will be decided by the SDN controller. And based on that, the SDN controller will update the routing tables or flow tables at each of the routers or switches. So the flow tables of the routers will be updated by the SDN controller. So once those flow tables are updated, the routers will send the data according to the flow tables updation, or after once it receives some data packet, it will check the flow table, and based on that, the router will send the data forward. The router does not need to update the flow table. Updating the flow table will be done by the SDN controller. So therefore, the routers will be responsible for sending data forward. So now the routers do not need to think. The routers do not need to form the or update the type tables. So because of that, the delay that is added at each of the routers is not available, or it is not happening. So I mean, if we take the perfect scenario, the routers do not spend time on thinking like what is the best route to send the data. They will send the data based on the updated flow table that has been updated by the controller. Then the data traffic will be sent very efficiently from through the set of routers towards the end destination. So SDN approach is likewise. So SDN is a technology that uses a software-based controller or APIs to communicate with underlying hardware infrastructure and direct traffic on network. So basically, software-defined networking is a technology that uses a controller that controls the like hardware infrastructure and direct the traffic on the network. And then there are basically, the network infrastructure that is that we can use to explain the software defined networking. So if we take, for example, like the situation where a certain user wants to communicate with another user or something, then we have the application layer. So the users will access the application layer and they will make a request. So first the users will make a request, and that request will be accessed by the network operating system. The request will be sent to one of the like access point, right? So it will be sent to one of the access point and the router, and that router will inform the network operating system. So in the network operating system, we have the controller. So the controller will receive a certain request or some message from the switch which is connected to this client. So some kind of switch is there. That switch will communicate with the network operating system, and the network operating system will have the controller, and the controller will give the necessary commands for each of the routers that need to connect in order to send the data forward. Right, so the controller will give the necessary commands to each of the routers and update the flow tables in each of the routers and create them in such a way, the tables will be created in such a way that the data packet is forwarded in the optimal route. So after that routing has been done, it will be received by the network application at the end of the communication. So basically, the the communication under SDN will consist of three layers. So application layer, which consists of the applications that the users use. I mean, customers, the clients are using the application layer. And then the transport, I mean, the layer which uses, which is having the controller, we call as the control layer. And then the layer where we have network components like routers and switches, we call as infrastructure layer. So apart from that, we have like different APIs. So we have a different API known as northbound open API and southbound open API. So northbound API is used by the network applications to access the controller. So they will use some API such as RESTful API. RESTful API, I think we discussed before. So they will use request response methods to access the network and thereby the controller. And then other APIs are also there. So basically, this is one of the common API used in the as the northbound open API. And the controller, once it gets such kind of request and it wants to it knows the entire network topology. Based on that, it makes the decision about certain routing path for the request, for the communication request. And the routing path will be communicated by the controller to each of these routers using an API called southbound API. So that API uses a protocol called open flow protocol. So open flow protocol will be used from the controller to control or communicate with the switches and the routers. So the communication between the routers and the controller will be done using open flow protocol and open flow API basically. So southbound open API is basically open flow API, and northbound open API will be used to communicate or used by network applications to access the network operating system or the controller. So basically the key elements of SDN therefore will be the centralized controller. right? So this is the controller will be the most important component of the SDN network architecture. So it is the key element of the SDN architecture. So centralized network controller is the main component of SDN. Then we secondly have the programmable open APIs. So we have two kinds of APIs, which are northbound open API and the southbound open API. So we have one API called northbound interface, which enables the network applications to access the control layers. So that is known as programmable open API. And then we have the other API, which we call as the standard communication interface, which is providing the interface between the control and the infrastructure layers. So in there, we do the communication from the controller to the routers and the network infrastructure. So if you have any questions, please let me know. Then now there are certain protocols that are used by the network, I mean SDN architecture. So basically, there are two types of protocols that are used. So network traffic control protocol and network device configuration protocols. So we are basically considering about the network infrastructure layer in here. So and the, I mean, protocols used in that uh, in those layers. So between control layer and the infrastructure layer. So the network traffic control is done using the OpenFlow protocol. So OpenFlow is the popular protocol that is used for the communication from the controller to the network infrastructure components such as routers and switches. So in here, some special function is there as features. Sorry, some special feature is there in the OpenFlow protocol. So basically, the OpenFlow protocol is able to is a open source protocol. It is an open source protocol. That means that anybody who want to change the source code, they can change it based on their own application and the use case. So like if they want to change the SDN architecture and customize it to their application, they can like do that activity by changing the code which defines this protocol. So so there's a certain protocol, I mean protocol is defined using set of line of codes. So OpenFlow protocol is written as some kind of software. So it therefore this software can be updated, right? The software is open source software. Open source softwares can be like visible. I mean, they are visible to the public, and the public can make changes to this open source software, and they can use it according to their own usage in a certain scenario. However, the original code cannot be changed, but they can copy and use it in their own applications. So the OpenFlow protocol is enabling the network to do the communication of the control messages to the routers. So the OpenFlow protocol basically control the data packet forwarding process in the SDN architecture, and it will be done in a centralized manner using specific functions. Right? So as I said before, the controller that is used in SDN technology is a centralized controller. It is a central like component which do the communication of how the network traffic should be communicated by other routers to a certain destination. So the controller, which is at a central point, is giving those commands to each of the routers that are involved in the communication. So the controller is a centralized controller. So the controller is able to see the total configuration of the total network. It is able to understand the total map of the network, and it is having the data regarding the total like network topology, and therefore it is known as a centralized controller, and it is doing specific functions, and it is like processing the data request and giving commands to the routers, and tell them like update the flow tables, and then the based on the flow tables the routers will forward the data. Next, the controller. As I said before, the controller is done using the control actions are done using software programs. The software programs are written using certain lines of code, and those lines of code can be modified by any person who's who's able to like who can view this code, right? So this protocol, I mean, open flow protocol that is used by this controller is a open source protocol. So it's I mean, software based code is available in the internet. So you can access it and you can manage, you can modify it, and you can use it for your own applications. So therefore you have the ability to like customize the open flow protocol according to your own needs, right? You can customize the open flow protocol based on your own needs. Then that is one protocol. And next protocol that would be is network device configuration protocols. These protocols, in contrast to open flow protocol, is not a open source protocol. It's not open source. It is not like accessed by any public person. It is only accessed by people who are running the company, who's having the SDN technology and so on, who has authority, right? So this protocol, basically network device configuration protocol, is used by authorized people, and that is one thing. The second thing is that these protocols are basically used for tasks like configuring the network devices, right? Before connecting the network to SDN architecture and its technology, we need to first configure our, I mean, first we need to connect all our devices to, I mean, all our routers and switches that we use for our networking. I mean, to for our networking application. Uh, First, I mean, before deploying the SDN technology, first we need to connect that to the controller, right, through the internet. And then we need to configure we need to like first, before doing the controlling action, we need to configure each of these devices. We need to understand their IP addresses and other kind of important details regarding each of these devices, and we need to keep a track of each of these devices, and also how the devices are connected to each other, the topology of the network and so on. Has to be like stored inside the controller based server, and such kind of um, initial work and configuration of the network is done by the network device configuration protocols. So network device configuration protocols are used to configure the devices connected to the network. So there are two main protocols that are used, basically simple network management protocol, and then netcoms protocol. A simple network management protocol is is all they are both like used for configuring devices, and these protocols are like not cannot be modified easily by outsiders. So the whatever the code or software written regarding this protocol cannot be modified by users. So the users have to just use whatever the protocol given, or whatever the like software features given by this protocol, and use it for their applications. So so therefore this protocol does not allow, I mean, the users to change the script that determine the protocol. So So that is the basic like difference with of the network device configuration protocol in contrast to the network traffic control protocol. In network traffic control protocol, we were able to modify the script that defines the protocol. In the network device configuration protocol, we are not able to modify the script that defines the protocol. Next, I would like to come back to the our like module basically, so which is about IoT. So IoT systems and how we can use the SDN technology in IoT systems. So IoT systems basically work with sensors and collecting data from sensors and communicating that data to a certain local access point, and from that local access point across multiple routers and switches they access a certain cloud-based server where data will be stored, right? So if we are using SDN technology, basically the architecture will be such that the routers and switches which will be forwarding our data will be controlled by the SDN controller. So the SDN controller will forward the data packets in the optimal route as much as possible, such that the data forwarding process will be low latent as much as possible, right? So the low latency in our IoT systems can be achieved using SDN technology, and also the data reliability that can be achieved using SDN technology. So that means the packet losses that can be reduced. So therefore, like we can achieve a lot of advantages by combining SDN technology in our IoT network systems. So if we add SDN technology to our IoT uh, networking system, then we can uh, obtain a lot of benefits. Then we have like an example scenario that I will use to explain more about the SDN architecture and its communication procedure. So basically, I will explain to you like using some example scenario. So we will consider a scenario where a certain client given in here, right, will try to access a certain database at a certain endpoint in the network. So the client will first send a certain request to the network, right? So if this is a software defined networking based architecture, then the software defined network architecture will be run in a way such that they are first like defining the controller. They are first, I mean, first like understanding the network topology of the system and defining the connection between different routers uh, and the topology of the network before doing the communication. So the controller will first understand the network topology and understand how the uh, devices are connected to each other. And then once a certain request is coming to do a certain communication by a certain client, the request will be sent to the controller. And the controller will decide what is the best path to forward the data from the client end to the database end. And based on that optimal path, the routers will send the data forward, right? So anyway, the SDN architecture separates the network into two systems, the control plane and data plane. So basically the control plane is separated from the routers. That means the routers do not do any control message communications. The routers do do not do, I mean, control message sending. It will be sent by the controller. So the controller is here. So controller will control or manage the message control message communication. So therefore, I mean, the controller is basically like holding the control plane of the network. The data plane of the network will be basically controlled by the, or will be consisting by of the network components, routers, switches. So they will form the data plane. The router switches will form the data plane. The controller will form the control plane, basically. So therefore, now the control plane and data plane are separated in this SDN technology. The control plane defines the traffic, network traffic, how it should be routed from one place to another place, and how the network topology is there. And also it will also identify whether there's some fault in the network, right? So we will come to that later. So basically it means that if there's some connection failure between certain routers in the network, it will identify, okay, there's some like problem between some between the link between the routers. So if there's some kind of a link outage, like some connection problem between some routers, then that router will not be able to reach any other router in its like in its neighborhood, or it might not have any other connection to reach another router. So if that is the case, the controller needs to decide, like, if there's an whether there's another alternative method to reach the endpoint from the starting point, or else, like, what are the other actions that can be taken to restore the situation. So basically I have talked about the control plane and the data plane here. So we will now start the situation where we um, talk about a certain scenario, and how SDN is working in that scenario. So SDN is able to handle uh, like uh, link management between devices as well. And so basically in here we are talking about the control plane. So the control plane, the functions of control plane will be handling device configuration and device configuration and understanding the topology of the devices, and then performing the link management between devices. So that means they will understand how the devices are connected to each other in the network, and if there's some broken link or unreliable link, they will manage the link between the devices appropriately to do the communication that is required. And then also the control plane will understand the network load. So they will understand the traffic in the network, and based on that network traffic, once a new request is coming through a certain client, they will decide what is the optimal method to do the data forwarding in the amidst the available data traffic. So apart from that, the client will also say the client needs some kind of quality of service. That means the client will say, I need low latency of about 1 millisecond, for example. Right? The client will say, I need to send my data really fast, and my data latency must be below 1 millisecond. Otherwise, I don't want to do the communication. I need this communication in this standard. And also I don't want packet losses below, above some kind of amount. Likewise, the client will define certain quality of service standards when making the request. So in that case, the controller needs to adhere to that command as well from the client. So the controller needs to understand, in order to address the quality of service, if the latency should be below 1 millisecond, then it needs to find the route that delivers the data really fast, and delivers the data packets really fast, and use the resources available in the network to do that. Controller therefore has to do that task. It needs to use the resources in such a way that it can send the data very fast from the client to the database in this case. And then therefore controller has to do a considerable job. And then controller also configures the connection paths or flows of the data plane. That means that it gives the updates to each of the each of the routers and routers which are connected in the network, and update the flow tables in those routers. So the connection path will be configured once the routing tables of these routers are updated based on the required communication, right? Now, if a certain client want to communicate from one end to another database, then based on that requirement, the controller will update each of these routers. The flow tables of each of these routers will be updated based on the communication request made by this client. So that routing table update will be done using the controller. So the controller will also use the control protocol known as OpenFlow to give commands to each of these routers. Next, we have a situation where we have a situation where sometimes the client, or the routers or switches in the network do not need the help of controller. Sometimes the switch will decide what is the best path to forward the data. If the switch can do it, switch will do it. Otherwise, if the switch decides to take the support from controller, the switch will send the request to give the switch a control command or commands on how to send the data forward. Right. So the switch will not only, all the time, switch will not rely on the controller. But if switch need, it can rely on the controller, or if not, it does not need to rely on the controller. Sometimes it will do the data packet forwarding by itself if it is capable of, depending on the request. If not, if it requires the communication service from the controller, then switch will send a request directly to the controller and say, let me know the optimal path to forward this data. Based on the control commands that is received from the controller, the switch will send the data forward. Right. So anyway, once the switch is talking to the controller, switch will use a secure channel to access the controller using the OpenFlow protocol. Apart from that, the controller will decide which optimal path should be used to forward the data. And controller will update the routing tables accordingly to allow the forwarding of the data in the optimal path. Then in some cases, there could be instance where some routers are not active in the network topology. If the controller understands that there's some router which is not functioning, then the controller will remove the records of such a router from its storage, and it will update update that information with all the other routers and switches in the network. So then some benefits are there. We have talked about SDN technology and its benefits all the time. So apart from all those benefits, some other benefits are there where we are able to understand some security attacks that are done to the network due to some unauthorized communication requests made to the network. So SDN controller, as you know, has the information about each of the routers that are connected to the network, right? If there's another another server or another server which is making communication requests to the like to the network, and asked to like I mean try to send a lot of traffic, try to add some traffic to this network without the like without without any kind of real real intention. If this if a certain outside like server gets connection to this network and add a lot of traffic to this network, then some of the routers might not be able to function appropriately. So in that case, the controller will deny the communication request made by some um, client based server, right? It could be some server which is run by a certain client or some kind of a program that will make those kind of unauthorized connection requests to the network. In such kind of case, once such kind of large amounts of communication requests are received by routers, the routers will be flooded with data traffic. Once they are flooded with data traffic, they might not be able to address the real request received by a certain legitimate client. So the legitimate client will not be able to access the resources appropriately when there's a lot of unneeded or unnecessary traffic in the network. So such kind of traffic are known as denial of service attacks. Denial of service attacks are caused by the communication requests made by unauthorized people. So, I mean, so denial of service means like it is shown to the routers and even the client that the service is no longer available, which means that uh, due to the high data traffic introduced by this the unauthorized server or any client which is connected to the network, the the amount of net data traffic added like stop the uh, our requests reaching the correct places, correct destination. Because of that, the routers will not function properly, and therefore the client will see that the service is not longer available. And I mean the client will be I mean client and the uh, even other like uh, components which are connected in the network will see this as a denial of service, and it will understand there's some problem in the network. So such kind of problems can be resolved using software defined networking technology, and the controller will take actions to such kind of unauthorized data traffic added to the system when such kind of scenarios happen in an unexpected manner, right? So such kind of unauthorized people can unexpectedly attack the system and attack the network traffic of the system. And in such kind of a case, the controller will quickly understand this is an unauthorized device which is accessing the system, because it has its network topology and it has all the details of the routers which are connected, and it also has the details about the client which is trying to connect to the network. And if there's other component or other network component, router or switch which is trying to connect to the system, the controller will know exactly that is an outsider. And based on that, network controller will take actions to like not accept any kind of request from such kind of unauthorized device or component, network component. Apart from that, once we have like large networks that we consider, we sometimes cannot control the network only using one controller. We might have to use multiple controllers. So in that case, we will have multiple controllers to control the data planes. So the controllers can be used like this. So one controller can like look after one like area of the network topology, and another controller can look after another area of the network topology, and the controllers can be synchronized with each other to make sure that the data communication can be happen from one destination or one point to another destination point. The controllers can work together to control the traffic in the network. Next, we have like the benefits that we can obtain from software-defined networking. So, as I said before, the ones we are using softwares, the cost will be reduced, and then the reliable routing will be increased in our systems. So, the optimal routes will be chosen to send the data, and also the packet losses that can happen amidst the network traffic will be reduced optimally by the controller. So the controller will decide the optimal path by taking a look at the total overview of the network, and based on that, the controller will make decisions about the optimal path through which the data should be sent, such that the network packets that are lost is minimum. Then we have service quality that will be maintained by the SDN architecture. So the controller will try to maintain the quality of service that was requested by a certain client. As I said before, the client will ask that some kind of quality of service, such as latency, reliability, to be maintained. So in that case, the controller needs to meet the service of quality, and this service quality can also be met using software-defined networking due to the lightness that it has in forwarding the data packets. And then security of the data packets, or the security of the communication, can also be established by the controller. The controller can request the switchers even to act as simple firewalls at the edge of the network, and prevent any unauthorized devices to connect the network. So it is anticipated that a lot of companies are going to embrace the software-defined networking concept and its technology in the currently and in the upcoming eras. So I think a lot of companies, like Facebook, Google, Microsoft, Yahoo, and so on, use this technology for most of their networking applications. Sometimes, however, we have some problems with this technology as well. So recently, I think Facebook faced an outage where it lost its connection with its customers for a considerable amount of hours. Right? It has happened. It is said that due to the problem in SDN architecture as well. So I have read in an article that the SDN controller that the Facebook used has had some errors, and that it has not been able to connect with one of the network components to which it should be connected. So because of that, it did not know the status of those components, and therefore it has lost the total communication with those routers and the network components that are maybe connected to other servers or something like that. So total network connection has totally gone out because of some problems that has happened at the SDN controller as well, and that has affected the total network communication. Next, we also have an enhanced version of the software defined networking, which is known as software defined wide area network. So software defined wide area network is the software defined technology used in the wide area network. So this is a very popular technology, and for companies like Cisco, Google, Microsoft, and Facebook, for example, they need to maintain their data centers in different geographical areas. So they can have some companies in one location and another data center or the network, the local area network in another location, I mean, in different countries, they will have their sites, their companies. Right? So the companies can be in one country in America and in the other one in Japan or something. So in those kinds of situations, the communication networks are in different sites, and those communication networks can be controlled like totally by another central controller, which will manage the the network in an overall manner by checking the requirements of each of its connected networks. So therefore, now we will have a certain controller which will connect, or which will do the communication or controlling part of the network. So this diagram shows like the total uh, area where the software defined networking is considered, and this is one of the local area networks. Likewise, different networks are connected to the main network through a set of routers and switches, and the controller component will be inside this white box, and the controller will do all the controlling functions along with other functions like vbond, vmanage, vsmart. They are the standard names used for like different functions in the software defined controller, and those controlling functions will be done by the headquarters of the I mean and of the network, and it will be used to connect with each of the local sites which are available in other countries and in different areas. And this one good thing about this is that the devices which are getting newly connected to any of the network can be directly connected to the internet through the routers and switches and connected to the main controlling unit. Once it is connected to the main controlling unit, the controlling unit will give configuration to each of the devices that are connected in these local sites and configure them to the total, global or the main network. And the controlling device will give necessary commands if required to each of the local sites. So the local sites can be controlled in one main location uh, using this architecture, and this kind of a controller which is in the white box can be stored in the cloud-based servers. So we can store in the cloud-based servers, and by accessing the cloud-based servers, the local sites can access the services from the controller, software-defined controller. So likewise, the software-defined networking has the software-defined the wide area network technology, which will uh, give service to local, or to different networks in different local area networks in different geographical areas. So basically, uh, with that, actually, uh, we can come to the next part, which is the benefits of network virtualization. So as I said before, it has many benefits. Out of them, we have the cost saving benefit, where we can save a lot of money by deploying softwares instead of hardwares. So uh, softwares are less costly than hardware infrastructure. Therefore, we can save a lot of money. And then we also have adaptability or agility in our networks. And also we have speed and availability in our networks because of this technology. So we can control our systems very quickly. And because of that, we can increase the speed of our data communication from one end to another end. Apart from that, reducing downtime and fault tolerance. That means if a certain link is broken, then the controller that is connected to the network will decide, okay, then don't use that path, use another path for sending the data. So therefore, the network is more tolerant to any kind of fault that might happen and will totally adjust very quickly using the knowledge in the controller. So these are some of the words that we have gone through in our lecture, which are having like abbreviations. So API means Application Programming Interface. CLI is known as Command Line Interface, and GUI, Graphical User Interface. M2M, Machine to Machine Communications, I mean Machine to Machine. NFV is Network Functions Virtualization. P2P is point to point. Software defined networking is SDN. SD-WAN is software defined wide area network. Virtual machine is given by VM. So basically with that, I come to the end of, today's, content basically. If you have any questions, you can let me know. Apart from that, like in today's class, I have covered basically two main components, which are related to machine to machine communications, and then we started the network virtualization. So in network virtualization, we have talked about network function virtualization and software defined networking. Network function virtualization means we are using software to program network functions. So network functions such as routing, firewalling, load management, fault detection can be software, programmed using software programs. And network function virtualization means that using softwares to do some networking function. So once we install that networking function in a certain virtual machine that we can again put in a server, then that virtual machine can do the network function once we are giving the input data and once we give the process, once we give the code, everything, input data, the output will be given to us by the software. So the virtual machines, using the virtual machines, make it easy for us to install softwares whenever we need, and remove the softwares from such kind of virtual machines whenever we need. We don't need to change anything. Software in the software, the virtual machine, we can remove and add softwares when we need. So that increases flexibility. And then we have the software defined networking, which control the such kind of servers which are having virtual machines and which can perform functions of routing and forwarding data packets and the same functions that are done by routers. So software defined networking will control the network, network components like routers and switches and these kind of virtual machine installed servers which can perform routing, and the controller, software defined controller will give the control commands about forwarding the packets. And based on that, the data will be forwarded by each of the routers. And then the communication will happen with low latency and much reliability. So it will be having a lot of benefits such as cost saving, security, agility, adaptability, and fault tolerance, and so on. So those are the basic concepts actually we discussed in today's class. So yeah, you have asked like how many lectures are there remaining for this module. So basically, I'm currently in the 9th or 10th lecture. So I think 4 or 5 more lectures will be there in this module. Another thing I wanted to mention is that I will stop the recording. So if you have